and welcome. RDNA for AI, professional uses, workstations, what's going on? Today, I've got my Falcon Northwest Talon system, the 96-core Threadripper with 768 gigabytes of memory. The focus today, though, is on the new workstation AI-oriented-ish GPUs from AMD, the R9700. I've got two of them, the Sapphire version, that I'm using in this system right now. Two in the same machine. We're going to deep dive into this. These cards are actually pretty awesome in real-world and creative, and AI-type workloads, especially in Linux. But they're first-class citizens in Windows as well. But let's start with the bottom line up front. If your workflow absolutely doesn't require CUDA or something that's NVIDIA only or NVIDIA only features, then the R9700 is one of the most compelling GPU options right now with its 32 gigs of VRAM. 32 gigs of VRAM, it's a 9070 XT with 32 gigs of VRAM. It's a blower design, it's roughly $1,300, and the power consumption under full load typically in my testing stays around 280 watts. 300 watts, something like that. Whereas the, 5090, 600 watts, twice as much. For creative workloads, you're going to see about 70 to 80% of the performance of a 5090, so it is a little slower, but at half the power. And the VRAM in the 5090, of course, is 32 gigs of GDDR7. The memory bandwidth is almost 3 times what AMD has in the R9700 at 640 gigabytes per second, and it's only 256 bits wide, but I wasn't expecting performance this good from the R9700. For AI workloads, especially more on the inference side than fine-tuning or compute-oriented tasks, you'll see what I found, and I think you'll think it's pretty impressive. So if you're someone who is working on content creation, emulation, AI inferencing, and you want a card that's a really good value, you're going to want to take a look at this. If you're a gamer, you're probably immediately going to notice the blower-style design of the card. It's a workstation AI card. It's designed for efficient use cases, efficient airflow, thermal and space footprint, minimal interference with other cards and multi-card systems. In my system, I have 2 of these GPUs installed, giving me a total of 64 gigs of VRAM. Yes, that's pretty awesome. So I can render large scenes, do stuff with large models, do memory-heavy workloads. It's very difficult to manage 2 5090s in this system, let alone 4. Whereas I could actually put 4 R9700s, and it would be doable in most system configurations. Let's pull up the full spec table so we know exactly what we're working with the R9700. It's AMD RDNA 4, 64 compute units, 4096 stream processors, 128 AI accelerators. It's up to 2.9 gigahertz boost frequency, 47.8 teraflops, peak single precision FP32, 95.7 teraflops of FP16 matrix, peak int 8 matrix is 383 tops. With structured sparsity, you could get that up to 766 tops, peak int 4 matrix, 766 tops, 1.5 petaflops, and it has 64 megs of infinity cache. So this is a serious workstation AI-oriented card, but at a price point that's designed to undercut many of NVIDIA's pro data center-oriented GPUs. For example, listings show MSRPs of some of NVIDIA's data center cards well over $5,000. This card's going to be about $12.99, give or take. AMD's in a tough spot here because 32 gigs on the NVIDIA side, that sounds like a 32 gig 5090, and you can get one of those for just over $2,000. Are there folks out there using a 5090 in lieu of more expensive RTX Pro graphics cards? Yes, sure, but those, it's not really... It's a thing, but you can use the Pro driver. It's fine, but that's why I say it's problematic for AMD because it's like, oh, this is Pro, and it's like we're going to qualify our drivers and do all the same hard stuff, and they're not going to be able to charge $2,000 for their GPU. It's going to be about $1,300. It's got to be tough for AMD because it's like it's so good, but also like I'm sure they'd like to charge more. Okay, with those specs in mind, let's dive into how this card performs first in creative workloads on Windows, and then in AI workflows in Windows, but also Linux. Like we'll get over into the Linux system when we tackle AI. So, yeah. I'm running 2 of these R9700 cards in our workstation platform. Remember, we've got 96 CPU cores thanks to Threadripper and 768 gigabytes of memory in this system. The idea here is abundant CPU and memory headroom that ensures the GPU is not the limiting factor. Or the CPU and the RAM is not the limiting factor. The GPU should just be able to do whatever it can do. But I've also got a total of 64 gigs of VRAM in the multi-GPU configuration. So some software can use that, some not. For Puget Bench, we use the standard Puget Bench suite for creative applications. This gives good baseline an idea of what you're going to have across many workflows. But because our system's unusually large with all those cores and that much RAM, we had to build a custom test in Nuke at 4K, 8K, 6K, and 12K. And so the GPU can be more fairly tested in large memory, large scroll situations more than Puget covers. So for Nuke, what were the results? Now for Houdini and Nuke, it's really interesting because the R9700 is at a little bit of a disadvantage in terms of memory bandwidth, but like I say, for raw compute workloads, when you get down to it, a lot of the workloads are about 70 to 80% as fast. And that kind of makes sense because NVIDIA also has their Max-Q version of their workstation cards for like the RTX 6000, and the RTX 6000 is basically a 5090 with 96 gigs of VRAM, but there's a 300 watt version of that. And that is also about 70 to 80% as fast at half the wattage for most things. It just depends on what you're doing. Some things, I'm getting a little off track here, but Houdini and Nuke, there's a guy in the forum that helped us with a custom project, and so there is some benchmark tables you can dive more into Houdini and Nuke for that specific thing. But at the same time, I also reached out to a creative agency that actually uses Houdini and Nuke. And with one of their real-world projects, which is different than the other real-world project that is on the forum, we decided to do head-to-head tests with 1 or 2 GPUs, because some things scale to 2 GPUs, some things do not. But mostly with 1 GPU, the performance was really close between AMD and the 5090. The AMD card actually pulls ahead in some cases, which suggests that when you have the ability to take advantage of a hardware encoder, it's going to perform a little better than the hardware encoders on the 5090, and that may be because NVIDIA spent more of their transistor budget on other stuff in the 5090. Like, maybe that makes sense. But I was kind of surprised by this result, and it may also be project specific. But we were scaling from 4K to 12K textures, and this operation is mainly, it's relatively simple in terms of computation. Like, there's a blur step in there, but it's mainly doing texture manipulation, and there really wasn't a significant performance difference across a couple of these different scenarios with Nuke. So if that sounds interesting or you want to get into that, then that's what the forum is for. Let's have a discussion. Let's experiment with various projects, because that's what we've been doing. But it's also a pretty exciting result for AMD. It means that these commercial companies should sit up and take notice of what's going on with these cards. Still a little disappointing things like, Octane Render, it's like a CUDA only thing. You're going to run into a lot of things that are CUDA only. But for the things that work, this is an incredibly promising result. 32 gigs of VRAM plus the capabilities of a 9070. It's interesting. It's interesting, I think. But this is also maybe something that deserves another video and revisiting. And also, I think the ground truth of the situation, you probably should dig into a little more and find in the Level 1 forums. For Puget Bench and After Effects, the 5090's got a 2-to-1 advantage over the 9700. Not necessarily unexpected. Because CUDA and the special effects. I mean, that makes sense. After Effects relies on the whole CUDA ecosystem. The 5090 does have more raw memory bandwidth and compute, and it doesn't really scale well to multiple GPUs. In Photoshop, the performance was near identical between the two GPUs, the 5090 and the R9700. That shows that for non-CUDA workflows, AMD is very competitive. In Premiere, the 5090 scored 170,000, the R9700 is around 120,000. The R9700 is about 70% of the 5090 performance here. Video codec performance, however, was pretty awesome. The R9700 can do H.264, H.265, AV1. It has hardware encoders and decoders, so the performance was really similar. It just depends on the application. For creators doing lots of video editing and export, it seemed like it's pretty excellent support. And OBS, which is what I always get sucked into testing, it worked really well. What about Blender? Blender, I was surprised that the samples per minute between the 5090 and the R9700 were scaling about the same. The R9700 card, it jumps, it's very competitive. It's surprisingly competitive, and I was surprised by that. So the value here is really strong. I mean, theoretically, the 5090 should be faster because it's got more compute and more memory bandwidth. This may be something I need to revisit. For Geekbench and OpenCL mode, we observe, 262,000-ish on the 5090 versus 179,000-ish on the R9700. So 68 to 70% the performance of the R9700 versus the 5090. And in artificial benchmarks like 3D Mark, the 5090 still dominates, where, we got CUDA or NVIDIA specific features. But the performance here is shockingly good because this card is about half the cost. We also try to test Octane Renderer, but Octane Renderer is still CUDA only as far as I'm aware. And so that's just a reminder that if your software is super optimized for CUDA, you're going to have problems still in 2025. But the R9700 is a very compelling value for everything else. Companies that ignore AMD at this performance level are owning themselves, I think. I mean, it's kind of embarrassing if the GPU is this good that you can't get software support from third-party companies, because there would be no reason not to. In other words, if these cards work as well as they do at this price point, you could just run these cards with your software and people would have a good experience with your software at a lower price. But like, people will spend the same money on the GPU, they'll get more GPU or multiple GPUs. So why not? Now, on to AI, and to be perfectly transparently specific, inferencing on Windows, inferencing on Linux. On the Windows side, I primarily tested LM Studio. AMD hardware in LM Studio uses Vulkan as its backend still, but on Windows. Now, there's also ROCm. The ROCm software stack is from AMD. It's weird because ROCm on Windows has become a first-class citizen in the AMD ecosystem. So in Windows, you're mostly using the Vulkan compute path, which is also pretty mature, but is a step behind native AI hardware stacks. But LM Studio still just runs Vulkan. In Linux, however, LM Studio better uses ROCm in the HIP backend, and they seem to treat it more mature and like more of a first-class citizen than Windows. So on Linux workflows, it works better and with the HIP backend, which is interesting. So in my config, with two R9700s, I managed to load GPT-OSS 120B. That's a 120 billion parameter model. I achieved nearly 150 tokens per second, and the time to first token was less than a quarter of a second. That is very, very good local inference performance from a couple of GPUs that are like, you know, $2,600 total. Remember, these GPUs, 256-bit memory bus, about 640 gigabytes per second for each GPU, so versus the 5090, which is like 1.7 terabytes per second of memory bandwidth with the GDDR7. So this is an excellent result. I mean, yeah, the R9700s aren't matching the 5090 memory bandwidth, but this is good enough that I'm trying to plan a 49700 build. Maybe I can get that in here and have enough airflow somehow. For image generation workflows, it also works great. AMD is now a first-class citizen in the Windows ecosystem with Comfy UI. Comfy UI worked out of the box with the R9700 as of, like, you know, now, when this card is launching. You know, int4 and FP8 and bfloat, you know, what AMD promised in terms of the performance and their specifications, it performs. You're going to see excellent throughput at all of those configurations. Now, switching to Linux. Linux was a dream for these cards because of the 32 gigs of VRAM. That opens up some really interesting options. I was also able to run vLLM from AMD, the ROCm version, via Docker, configured for tensor parallelism of 2, so that I could get everything to run across both GPUs. Here are the benchmark results from that, and that is using HIP and ROCm. And this is also important to note because HIP is actually outperforming Vulkan here in Linux. This is a major milestone for RDNA and AMD and what they have done. AMD's ROCm ecosystem originally is built for CDNA GPUs. These are compute data center oriented GPUs, meaning that large dies, server, power budgets, memory architecture tailored for high performance computing. And RDNA is what's used in our R9700s is really a gaming oriented architecture repurposed for this workstation AI. So support for HIP and RDNA is still maturing, and some features may lag and the drivers may be less stable. You may have to use some libraries that are a little experimental, and that's stuff that is in the Level 1 forum that we can talk about. But out of the box, Linux today, it was basically usable as is, which is fantastic. So you need to check your specific machine learning framework and some other stuff. But it is really nice that if HIP is having a problem, you can fall back to Vulkan, and the Vulkan performance is really good. Another really cool thing that they enabled on Linux is ECC memory. So ECC memory is now a software thing generally. That's true of Team Green or AMD, either one. And these Sapphire cards have an option that you can toggle on ECC. There are also 4 DisplayPort 2.1 outputs. There's no HDMI. I actually like that. Yay. Linux, because the HDMI interface is always a little sus in Windows because of DRM and dumb reasons. But 4 native DisplayPort, 2-slot design, blower, design with multi-GPU in mind, uses the 12V2 power connector, but it's a 300-watt board power design card, but in my testing, it floated around 280 watts. Excellent cards for inferencing. I've got 2, and it scales really well. But if I go 4, I can have 128 gigs of VRAM. That is amazing. And a power budget of roughly $4,000. What's he hinting at with the price budget of $4,000 in inferencing and VRAM? I don't know. What could he be hinting about? And so if you side by side the R9700 inferencing performance against the 5090, well, the 5090 is a speed demon. It's got more compute, more memory bandwidth. How could it not win? And yet, if you scale up to two R9700s, which is about the same cost as a 5090, maybe a little more if you can get a Founders Edition at actually $2,000, maybe a little less depending on retail, then it's a similar inferencing performance. If you're in the CUDA ecosystem and all that kind of stuff, then yeah, 5090. But keep in mind that R9700 is less than half the power of a 5090. So again, it's like you could run two R9700s and maybe get similar or slightly better inferencing performance in some scenarios, or a bit worse inferencing performance in other scenarios at a similar power envelope. But double the VRAM. So what's got me excited here is 128 gigs of VRAM plus 768 gigabytes of system memory opens up a whole universe of possibilities for AI that can run on this machine. This machine would be able to do the work of a machine that costs $250,000, but even with this configuration, this top-end insanity, it's not going to cost anywhere near $250,000. I'm also reasonably certain that multiple GPUs is going to work really well on this platform, because there's a weird thing. If you got RTX Pro 6000s, you might have noticed that on the Intel platform, like with Sapphire Rapids, the peer-to-peer, like how fast one GPU can communicate with another GPU, runs at roughly PCIe Gen 4 speeds. And I thought that was something on the Intel platform. But somehow the R9700s avoid the half-speed peer-to-peer bug that the RTX Pro 6000s trigger on Intel Sapphire Rapids systems. I'm not sure why. The Intel systems, they only see 40% of the performance for peer-to-peer when you're doing RTX Pro 6000s. But even on AMD EPYC, the R9700s are about 5% faster than the RTX Pro 6000s. So these GPUs can communicate among themselves on a PCIe bus even faster than the RTX Pros by about 5%. And we know Intel's working on Battle Matrix. They're going to have 4 GPUs as well. But AMD doesn't really require any special software. They don't have any special enablement. It's really just up to the thing. And vLLM parallelism for 2 worked great right out of the box with the AMD ROCm version of vLLM that AMD put together. So, and you're going down a rabbit hole with AO Triton and some other things like that. You're going to have to hit up the forum for the specifics, but the performance was really good. So let's pull everything together. These GPUs literally launched today. You can buy them in Micro Center and other places, but literally just like today, like fresh out of the box. And if you've got a 9070 XT, you can experience the software now. So like if you're curious, is like, will the software work? Try it on a 9070 XT. If you don't run out of VRAM, it's going to work on a 9070 XT, or not work on a 9070 XT. Your mileage may vary. If your workflow runs fine on a 9070 XT, you should be fine with an R9700. It's the same engine, it's just going to have double the VRAM. And the bottom line here is that for creative and AI workflows that don't strictly require CUDA or NVIDIA exclusive features, the Radeon AI Pro 9700 is exceptionally compelling. I mean, you get professional class GPU compute, good driver support across professional software, optionally error correcting memory on Linux. Generally the Linux support matrix here is pretty amazing overall, but it's a pretty solid platform, and ROCm for RDNA has never been more mature. So if you're wanting to get your toe in the water there and maybe see how the performance is at like 40 to 60% of the cost of the competing team, these are forward-looking, like sort of aspirational things, but it is exciting and fun to think that, oh yeah, I could deploy 4 GPUs, I have a total power budget of 1200 watts, and have 128 gigs of VRAM, and have some pretty serious performance. But I think this also is a herald, a portent of things to come, like RDNA 5, RDNA 6, maybe the merging of RDNA and CDNA back into UDNA. I think that AMD's future is really bright here, considering how well put together this is and how good this was out of the box. Because I've experienced things out of the box in prior generations, and this is the best that it's ever been. It is very nice to see that. And it's also really nice to see that Linux continues to be a first-class citizen for AMD, but that also for the Python enablement and PyTorch and everything that AMD is doing for native development on Windows, that they're not neglecting Windows developers or people that are working on Windows, and then they get their stuff working on Windows and then they deploy it somewhere else. AMD is they're dotting the I's and crossing the T's on that kind of a workflow, even though I wouldn't say that the ecosystem for that is as complete as what NVIDIA has. Nevertheless, for the price point, the level of performance here, I think is pretty solid. If you have something you want to test, or you want me to test, or we need to run more and different benchmarks, hit me up in the forum, because I literally, the R9700, they literally just launched. They're hot off the presses. So let's do more testing and more exciting, fun stuff, and see what they're capable of. I'm Whittle. This is Level 1. This has been a quick look at the R9700 Radeon AI Pros. 32 gigs. This is the Sapphire version. Fun times. All right. If you have any questions or I missed anything, hit me up in the forum. I'm signing out, and I'll see you there.